Okay. Piecewise function. Question 10. Sketch the graphs of the fx and state the domain and the range of the following function. Okay. First here the function fx equals to the x plus 4 and the value of x here less than 1. Okay. First you check the type of the function. Okay, first function fx here equals to x plus 4 and the value of x here less than 1. Okay, first function here the linear function, okay, x plus 4 and the general form of the linear function fx here equals to the x plus b. Okay, and this value of x here represent the domain of the function. Okay, domain of the function less than 1. Okay, so domain of the linear function here start from the negative infinity to x equals to 1. Yeah, and the second function fx here equals to and x here less than 4 greater than or equals to 1. Here is the constant function. Okay, and third function fx equals to the negative 5 plus x and x here greater than or equals to the 4. Okay, or here you can write down this function fx equals to the x minus 5. Yeah. Okay, first you sketch the graph of the first function fx here equals to the x plus 4. Okay. Okay, before you sketch the graph of the fx of the linear function, first here you find the y-intercepts and x-intercept of the function. So the y-intercept of the function when x here equal to the 0, so you find the value of y. So you substitute 0 here into the function, so you find the f0, yeah? So f0 here equals to the 0 plus 4 and equals to the fx here equals to the 4, yeah, and y-intercept equals to the 0, 4, okay, and then find the x-intercepts of the function. Y here equal to the 0, and you find the value of x. So here is a value of 0 here equals to the x plus 4, and x here equals to the negative 4. So x-intercept here exists at the negative 4, 0. Yeah. Okay, and then you check the point. You check the domain of the function. Domain of the function here, x here less than 1. Okay, so the first value of x start at the 1. When x here equals to 1, and you check the value of y. Okay, so you substitute the 1 here into the function. So you find the value of y. So f1 here equals to the 1 plus 4, and then point here at the 1, 5. Yeah. Okay, and then you sketch the graphs of the linear function. Okay, so this one is graph of the linear function. Okay, and x-intercepts and y-intercept of the function. 4 and -4. So here is -4. So you sketch the straight line here. Okay. And intercepts at -4, 0. And the Y-intercept here at 0, 4. Okay. Okay, and then first point here at 1, 5. Okay, so this point is color. Okay, so first point here is a 1, 5. Maybe here you put x here equals to the 1, and here is a value y here equals to the 5. Okay, and then you check the sign of the inequalities. X here less than 1. So here we use the open circle. Okay, we use the circle. Okay, so you put the circle here. Okay, at the 1, 5. Okay, okay, settle. First function fx here equals to the x plus 4. Okay, and then second function. Okay, and then second function fx here equals to 2. Say, so here is the constant function. Okay, constant function, and domain of the function here less than 4, greater than or equals to the 1. Okay, first function when x here equals to the 1. If you check the first value of x here equals to the 1, and you check find the value of y. Okay. Okay, constant function, you substitute any value into the constant function. The value of y here equals 2. So answer you here, x equals 1, and you substitute f1 here equals 2. Okay, and the second value when x here equals to 4, here is f4. Okay, correction. And then the value of y here equals 2. You substitute any value, positive or the negative value, you substitute into the constant function. So answer here equals to the 2. Yeah. Okay. And then you sketch the graphs of the constant function. Constant function is very simple. Here is the y-axis of the function. Okay, and here is the x-axis of the function. And then the value of fx or y here equals to. So you just draw the horizontal line between negative to the positive infinity. Yeah, horizontal line. And the value of y here equals to. Yeah, very simple. Yeah. And then here you put the first value x here equals to the 1. You check the sign here greater than or equals. So here using the then circle. So we use the then circles here. And the less than 4 here, you put the empty circle. So here is empty circle. Okay, first value 1, 2. So this one is then circle. When x here equals to the 1. Okay. And second here, 4, 2, maybe here we put the empty circle. And here value of x here equals to 4. Yeah. Okay, settle. Question, second function, the constant fx equals to. And then number 3, linear function. Yeah. So linear function, fx here equals to the negative 5 plus x, and x here plus 4, greater than or equals to 4. And x here equal to 0. First here you find the y-intercept of the function. X here equal to the 0. So you find the f0. Okay. and here equals to the negative 5 plus 0, and then y here or fx equals to the negative 5. So y-intercepts at the 0, negative 5, and x-intercepts of the function, y here equal to 0, so you find the value of x. So the value of y here 0, you put on the left hand side of the function, 0 equals to the negative 5 plus x, and x here equals to the 5, and x-intercept of the function exists at the 5, 0. Yeah. Okay, x-intercept and y-intercept of the function, and then here domain here greater than or equals to 4. So the first value x here equals to 4, and you find the f4. So 4 minus 5 here equals to the negative 1, and point here at the 4, negative 1. Yeah. Okay, and then you sketch the graphs of the linear function. Okay, y-intercepts and x-intercept of the function equals to the 0, negative 5, and 5, 0. This one, you put the y-intercept 0, negative 5, and here x-intercept here equals to the 5, 0. Okay, so this one is the linear function. First, here you labels the y-intercept, and here the x-intercepts of the function. Yeah. Okay, and here point here for negative 1. Okay, so for negative 1, and you check the sign greater than or equals to 4. So here is put the then circle. Yeah. So for negative 1, maybe start from here. Here is a 4. Okay. And you put the dot line here. Okay. And y here equals to the negative 1. Yeah. So at the 4, negative 1, so you put the then circle. Yeah, you put here. Okay. Okay, settle. Fx equals to the negative 5 plus x. Okay, first function, you check again the first function. Fx here equals to the x plus 4, and the value of x or domain of the function here less than 1. Yeah. Okay, and okay, first you check the domain of the function. Okay, so domain of the linear function x here less than 1. So this function or this linear function only define between 1 and negative infinity. Okay, start at the 0.9, 0.8 to the negative infinity. So you put the here you put the arrow here. So this one, this function only define when the x here less than 1. Okay, and this straight line you cancel. Okay, okay, settle first function, and then the second function. Okay, second function here, fx here equals 2, and value of x less than 4, and greater than or equals to 1. So you put the function, you put the domain. So this constant function defined between 4 and 1. Yeah. So between 4 and 1. Okay. And here you cancel. This straight line cancel. And here cancel. Okay. Okay. And then number 3, the linear function. Domain here greater than or equals to 4. Yeah. So greater than or equals to 4, start from here. 4, 5, 6 to the positive infinity. So okay, this one is defined greater than or equals to 4. And here you cancel this part of the function. Okay, you just pick the half of the linear function. Yeah. Okay, so first part of the function, linear here, less than 1, between infinity and 1. Okay, so here you cancel. So saya cancelkan tu. Oh, no. Okay. Sekejap eh. Okay. 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 So first function fx here equals to the x plus 4. Okay, so you just sketch this function less than 1. Okay. And here between 1 and 4. And then number 3 here, x here greater than or equals to 4. Okay, so you combine all the piecewise function here. You combine here. Yeah. Okay, first function from the left of the function. Here the graph of the fx equals to the x plus 4. Okay, so here this one you put the dash. Okay. Okay, you combine all the function. So first here, when x here less than 1, and here you put the empty circle. Yeah. So you label the x-intercepts and the y-intercept of the function. X-intercept here 4, negative 4, and the y-intercept here equals to the 4. Yeah. And then the second function between 1 and 4. So here the constant function. Here is the dot circle. You put the circle here. And here is the empty circle. You put the dot line at the 4, 2. Okay. And then the third function, fx here equals to the negative 5 plus x. So this one, the value of 4. And then y here equals to the negative 1. Okay, settle. Yeah. Okay, and then from the graphs of from this graph, you find the domain, find the range of the function. Okay, so domain of the function from the left to the right of the function. So from the left here, start from the negative infinity. Yeah, okay, start from here. Negative infinity, negative 4 exists. X here equals to 1 exists. And continue to the 4 exists, 5, 6, 7 to a positive infinity. So this one you put the arrow. Okay. Okay, so domain of the function here for this function defined for all the real numbers. Yeah, negative to the positive infinity. Okay, and second you find the range of the function. So range of the function bottom ups. Okay, okay, the minimum value here start at the negative infinity. Okay, you start from the negative infinity, and y here equals to 1 define, and then ups to y equals 2 define, y equals 5 define to the positive infinity. Yeah, so answer you here, range of the function defined for all the real numbers. Okay, okay, sama saja. Yeah, okay, settle. Okay, and the exercise. Okay, exercise here, you sketch the piecewise function. Fx here equals to the 2 minus x, fx equals to the 3, and last here fx equals to the x squared plus 1. Okay, this one, you just list down the type of the function. So here the linear function. Okay, three type of the function. Fx here equals to 2 minus x, the linear function. Fx here equals 3 constant, and fx equals to the x squared plus 1, the quadratic function. Yeah. You find the y-intercept, x-intercept of the function, and then you sketch the graph of the linear, graph of the quadratics, and last you combine all the function. Yeah. Mudah saja. Yeah. Okay. And the last you find the domain and find the range of the function. Okay, exercise, and then question number 2. Okay. Okay, function here fx equals to the 8, and fx here equals to the x plus 4. Okay, just okay. First here, um, fx equals to the 8, and the domain of the function here less than 4. Yeah. So here the constant function. Constant function, you just sketch the horizontal line. Okay, so here is a horizontal line. Okay, settle. And the value of x here equals to the 4. Okay, here you put the circle, dot line. Okay, the x here equals to 4. Okay, okay, and okay, and here less than 4. So here you put the empty circle. Is x here greater than or equals to the 4. Yeah, here it is the circle. Okay. So from the left of the function, we use this notation, empty circle, and then at x here equals to 4, we combine with the circle. Okay. So this one equals to the circle. Okay. If from the both side here, empty circle and plus the empty circle, so here equals to the empty circle, and here then circle plus the then circle, and here equals to the then circle. Okay, so we use the first empty combine with the then circle, and here you put the then circle. Okay, so empty and the circle you combine, so here is you put the then circle. Okay, and here you draw the straight line. Okay, fx here plus 4, straight line to the positive infinity. Yeah, yeah. Okay, settle. Okay, settle piecewise function. Sum difference and products of the function. Okay, fx and gx are the function with the domain df and dg, and you find the sum of the function. So fx plus g here equals to the f of x plus g of x. Yeah. Second difference, f minus g, f of x here minus g of x, and here products of two function, fx here times gx. Okay, this one the basic concept of the difference, products, and the sums of two function. Okay, and then you find the domain of the sum of two function. Domain of the f plus g here equals to the domain of function intersect domain of gx. Okay, you find the intersection between two function, and here f minus g, and here is products of two function. Yeah. Okay, question 11. Function here fx equals to the x cubed plus 1, and gx here equals to the x minus 2. Here the linear function. Okay, and the cubics x cubed plus 1. Okay, first function fx plus gx, and you start the domain for each function. Okay, very simple. Addition of the two function fx plus gx, x cubed plus 1 plus linear function x minus 2, and then answer you here x cubed plus x and minus 1. So 1 minus 2 here equals to the negative 1. So here is the answer. And you find the domain of the f plus g equals to the domain of the function fx intersect domain of gx. Okay, so you draw the number line here. Okay, first you draw the domain of the fx. Okay, so domain of fx define for all the real numbers. Okay, so domain of the linear function. So you start here negative to the positive infinity, and the domain of the cubic function negative to the positive infinity. Domain of the linear and cubics, all the real numbers. Okay, so first function, domain of the cubics, all the real numbers. It means start from here, start from the negative infinity to the positive infinity. Okay, define for all the real numbers. And second here, domain of the linear function dg, define for all the real numbers. Okay, and then you find the intersection of two functions. So this function intersect for all the real numbers. Yeah. Okay. Yeah. And then answer you here, domain of f plus g equals to the domain of f, intersect domain of g, and conclusion answer equals to the negative infinity to the positive infinity. Yeah. Okay, question A. Question B. Fx minus gx. Fx equals to the x cubed plus 1 minus gx minus x minus 2. Yeah. So answer here, x cubed minus x and plus 3. So here minus x and here plus 2. Yeah. 1 plus 2 here equals to the 3. Yeah. And then you draw the number line, sama. So here the domain of the cubic function, df, all the real numbers. And here domain of the linear function, all the real numbers. And then you find the intersection between the two number line. So this function intersect for all the real numbers. And answer you here negative to the positive infinity. Yeah. Okay, question C. Sum of the two function fx times gx, cubic function times linear function. Yeah, x cubed plus 1 times x minus 2, and answer you here equals to the x power 4 minus 2x cubed plus x minus 2, and this one you sketch the df. And here you find the intersection between df and dg. Okay, so you find the domain of the f times g and answer you here all the real numbers. Okay, very simple. Yeah, using the addition, subtraction, or you find the products of the function.